Continuing with the next example, what if we were going to take the region from the last problem, and instead of rotating it around the y-axis, this time we're going to rotate it around the x-axis. So what would that look like? I know it's kind of hard to imagine at first, but we're gonna take this, and if we rotate it, you know, we could make like a slice like that, or you know, a slice like that. So this time, instead of having a disc, we have a disc with a little hole. So it would look more like this. So instead of calling this a disc, or we'll call it something else, okay? It's kind of like a washer shape. So to get the area of this, it's pi times the big R squared minus the little r squared. So we have something a little different to do here. We have to identify the big R, and we need to identify the little r. So the big R is going to be, every single time, no matter what, it's going to be that 8 minus 0, or just 8. Little r, where the hole is just right there, or it'll be right here. Whoops, erase too much. All right, little r then is going to be x cubed minus 0. So now it's just as easy to set up the volume. Volume equals pi times big R squared minus little r squared. So big R squared minus little r squared. And our x values we're going from were 0 to, that's y equals 8, so that would be 2. 0 to 2. Pi times, I'm going to simplify this before I start, 8 squared, 64 minus x to the 6th. Okay, take the antiderivative. Okay, plug in the values. 64 times 2, and 2 to the 7th, that's 128 over 7, minus 0. And if I do this right in my head, I think it'll be 768 over 7 pi, but you should check that out. All right, so what we did, let's break that down. What we did is we made washer shapes instead of just a disc. So we have the area of the big circle minus the area of the little circle. And so remember, you have to make sure that you do pi times the radius squared when you set up your integrals. All right, so this, we're going to call it perpendicular, because we're perpendicular to our axis of rotation. So maybe you'll remember that we had perpendicular and perpendicular. So right now we're kind of focused on rotating, making our slices perpendicular to the axes we're going to rotate around. All right, so let's just do another one like that. We have the graph of cosine. Yeah, that would look something like that. And then we have sine. Something like that. We're talking about the first quadrant. It's revolved around, this time we're going to revolve around the x-axis. Okay, so if we took this shape, we would make these nice little washer slices. Okay, so the area for a washer is pi times big R squared minus little r squared. So we need to identify our big R. Okay, so our big R is going from here to here, here to here. So it looks like we're going from the blue function, that's cosine of x. Our little r is where the hole starts, so that would be here, here, so that's sine of x. Set up our integral, and cosine squared minus sine squared. Is that a trig identity? And we need to write our bounds. So where do sine, we start at 0, but where do they intersect? Well, sine and cosine are the same at pi over 4. Okay, So yes, to take the antiderivative, first I'm going to simplify that using trig identities. Hopefully you know that's the same as cosine of 2x. Okay, so take the antiderivative of that. So it'd be sine of 2x, but then times 1/2 to correct for that 2 on the inside. We're evaluating that from 0 to pi over 4. So we plug that in. Sine of 1/2 pi is 1, so that's 1/2. Minus sine of 0 is 0. So our answer is, 1/2 pi. Okay, so very important things to remember. Draw a picture. You have to identify the region first. That helps you to figure out what each R value is. We're using slices that are perpendicular to the axis of rotation. And this is a good idea. Before writing an equation for big R or little r, draw them on your diagram. If you can draw it, then you can write it. So we're either going to be doing top minus bottom, just like when we did area, or right minus left. Okay, and a lot of people square the whole thing, like pi times the radius squared, like that. Don't do that. Make sure each R value is squared. Okay, so this is just a bunch of practice with the perpendicular method. We're going to just do a couple for this video to kind of get an idea. Okay, so let's draw our region. We have y equals x squared. Okay, so we're talking about this region here. And we're going to rotate it first about the x-axis. So we're going to rotate it around this line. So let me do this. So we are going to have a washer. So the area is pi times big R squared minus little r squared. Big R would be top minus bottom, x minus 0. Little r would be x squared. So the volume would be given by pi. And we're going from 0 to 1 where they intersect. Big R squared minus little r squared. Okay, antiderivative. Plug it in. 1/3 minus 1/5 minus 0. So that would be what, 2/15 pi? Okay, so that's it. So we're going to go through the setup of each of these. I think that you can do the integration part yourself. If you need help, just ask. All right, so for the next example, we have that same picture, which I should just get a good picture and keep it. Group it, copy it, and paste it. Yeah, I know you can't do that, but that's okay. Oops. Come on. All right, so let's talk about this. Now we're going to rotate about the line y equals 2. So that'll be up here. So when we rotate this, we're going to have a really big hole. It's not very representative, but you kind of get the idea. Okay, so we have a washer again. Area equals pi times big R squared minus little r squared. Big R. Okay, so I'm going to go top to bottom, top to bottom. So that is going to be my high point 2 minus the bottom, which is x squared. Okay, my little r here to here, here to here. So we're going 2 minus x. Okay, so then lastly, I'll set up the volume. Pi times the integral from 0 to 1, big R squared minus little r squared dx. Okay, and then you could multiply and find the antiderivative and solve. Okay, the next one, y equals -5. That'd be somewhere down here. So when we rotate it, we'd have this big circle and we'd kind of have a little circle for each slice. So the area, we got another washer, big R squared minus little r squared. Set it up. Oh, don't want to do that. Get back there. Big R, top minus bottom, top minus bottom. So it's x minus -5. Okay, little r, here to here, here to here. So it's going to be x squared minus -5. Okay, and then our volume, pi, times the integral from 0 to 1, big R squared minus little r squared dx. All right, so finally we have something a little bit different down here. Now we're going to rotate about the x-axis. So the width of that would be dy, so we know everything has to be in terms of y. But that's okay because this one's easy and the other one's also easy to solve. We're using x squared, so then that would just be square root of y. Okay, so our big R, oh, we got a washer. We should write this, area equals pi times big R squared minus little r squared. Big R, be square root of y minus 0. Little r is just y. So then our volume would be given by pi. And now we're going from y values. It's still 0 to 1 because the point up there is 1, 1 where they intersect. 0 to 1, square root of y squared minus y squared dy. Okay, this time we are going, let's pick a different color. Orange, that's exciting. X equals -1, so that would be a line over here. Okay, so we still have a washer. Area equals pi times big R squared minus little r squared. Big R, and again, this is a y value, the width, it's a difference of y, all right, or differential. So we have square root of y minus -1. Little r is going to be y minus -1. So our volume is going to be given by the integral, pi times the integral from 0 to 1, big R squared minus little r squared. And I would highly recommend, if you were going to solve this, to expand that out and simplify as much as you can. All right, so I think you get the idea here. I guess we could set up this last one, why not? The line x equals 17. Well, that would be, let's move that on over. That would be somewhere over here. We'll do this color. Maybe we will. There. Somewhere way over there. That's x equals 17. So you'd have a really big washer with a really big hole. All right, so the area is pi times big R squared minus little r squared. Big R would be 17 minus y, little r, 17 minus square root of y. And so then we'd set it up, volume equals pi, integral 0 to 1, big R squared minus little r squared dy. All right, and I think that's a good place to end for today.